Today, we are going to talk about the study and develop magnetic activated white charcoal for heavy metal absorption. We have three member group in our group, and we have two advisors. This is our topic that we would like to mention today. Let's start with introduction. Nowadays, water from natural sources is often contaminated with various heavy metals. When these metals enter the body of living organisms, they can lead to serious health issues. There are several industrial methods commonly used to remove heavy metal from water, such as ion exchange and chemical precipitation. However, studies have shown that these methods are costly and not very practical when applied to large volumes of water. Recent research suggests that one of the most effective ways to remove heavy metal is by using magnetic nanomaterials that can directly absorb the metal from water. Among the widely used absorbent, activated carbon is especially popular due to its efficiency. However, commercially available charcoal often pose challenge. It's difficult to separate from treated water once contaminated, which increase the overall treatment cost for manufacturers. Therefore, our project group used white charcoal for instead because it's more rigid, more porous. It causes less effect on the pH of water. It has very little effect on the COD percentage. And also there are less toxic residual from the production process. In our project, we focus on studying and developing white charcoal by enhancing it with magnetic properties. The goal is to use this material to absorb heavy metal ion from contaminated water sources, while also allowing the absorbent to be easily recovered and reused. We have two objectives. First, to analyze activated carbon from white charcoal with the aim of efficiency removing heavy metal from industrial wastewater. And the second is to enhance white charcoal-based activated carbon with magnetic property, making it more suitable for post-use removal after heavy metal absorption.
Next, we divided the methodology into two parts. First, the production of activated charcoal and magnetic improvement, and the second is absorption of heavy metals. We start off with mixing the white charcoal into the potassium hydroxide solution to make it an activated carbon. Then we stir it for 3 hours, then we filter it. After that, we wash it with the DI water until the pH is neutral. Let it dry, and then we will get the activated white charcoal. After that, we mix the white charcoal powder into the solution containing iron chloride, sodium acetate, and ethylene glycol as a solvent. Then stir it at room temperature. After that, we pack it in an autoclave and go through the hydrothermal process. Then we wash it with the ethanol and bake it until dry. After that, we get the activated white charcoal with magnetic properties. Then, for the absorption of heavy metals, we put it into two cases. First one is the contact time. We put 7 sets of activated carbon with same mass into the heavy metal solution. Then, take the charcoal powder solution to shake on the orbital shaker with 7 different amount of times. After that, measure the heavy metal absorption with atomic absorption spectrophotometers. The second one is finding the right mass. We put 4 sets of carbon powder of different masses into the heavy metal solution. Then, we shake the charcoal powder solution with the same amount of time. After that, we measure the heavy metal absorption with the atomic absorption spectrophotometers.
And instead, we will take this white charcoal to analyze functional groups. As we can see from this graph, it has a deep peak at 576, and currently it can identify that magnetic function has exists on our white magnetic charcoal.
Next, we are talking about the results and discussion. First, we'll study the effect of time. BIIC will vary the time and QF, which is the concentration of the final sample. We can see that the absorption becomes constant after 30 minutes, meaning it reaches the equilibrium. This shows that we can summarize the absorption capacity at each time point, where we select 30 minutes as the point where the absorption reaches the equilibrium. In reality, to be safe, we usually use an absorption time greater than 30 minutes to ensure true equilibrium. Thus, we'll design the next experiment based on this and move on to part 2. Besides studying time, we will also study the effect of varying the amount of charcoal to find out which material absorbs better. We will vary the amount of charcoal, compare how the absorption capacity changes on different materials such as zinc, copper, and cadmium. We can see that at a low amount of charcoal, the absorption might not be efficient, but at a high amount of charcoal, the absorption should be more efficient. This shows us that the higher the amount of charcoal is, the better the absorption is. Next, we study about the kinetic study. We conduct kinetic studies to understand why absorption reaches equilibrium at around 30 minutes, differing from other studies that took around longer. For example, the Turian pills, which took 60 minutes. However, since we only have 2 time points, we can fit the data through pseudo first and pseudo second order model. From this kinetic study, we found that the absorption matched better with the pseudo second order model, meaning that all three metals reaction is controlled by a chemical absorption. Next, we studied the model isotherms. Besides that, we also compare the isotherm data. If it's a Langmuir, it's a monolayer absorption, and if it's a Freundlich, it's a suggest multi-layer absorption. Our data show that Cu or copper absorption on iron materials fits the Langmuir isotherm, while zinc and cadmium fits the Freundlich models.
In last step, we will analyze percentage of metal that was absorbed by biometric charcoal. As we can see from this bar chart, we can infer that copper 2 ions are absorbed the most and zinc 2 cadmium 2 ion respectively. In conclusion, it can indeed be used to absorb heavy metals, although its efficiency dropped by 58%. However, this trade-off allows the material to be reused multiple times, making it more sustainable in the long run. The optimal absorption mass for heavy metal removal was found to be 1 gram of charcoal per 50 milliliters of solution containing 3 types of heavy metal, each at a concentration of 5 ppm. It was observed that the reaction reached equilibrium after 30 minutes. Accordingly, to get the best absorption result, we should keep it in a solution for at least 30 minutes. Analysis revealed that the absorption of all three heavy metal ions follow a pseudo second-order reaction model. And at last, it was found that the absorption of copper 2 ion follow a monolayer absorption model, while the absorption of zinc 2 and cadmium 2 ion correspond to a multilayer absorption model. And this is our reference. Thank you for attention.